going to go through page 7 of the Geometry 3F pack, which is all about area of a parallelogram. Before we do that, let's have a look at how this is found. Okay, so we're going to start with the area of a rectangle. So hopefully you'll know now that the area of the rectangle, to find that quickly, we just times the base by the height, or the width by the height, however we want to say that. So the area of this rectangle is 6 times 4, 24 square centimetres. Okay? If we cut the shape like this and remove a triangle, the area of the shape, the shaded blue shape, is still 24 square centimetres. Just because we've cut it and moved part of it away doesn't mean we've changed the area in any way. And if I move that triangle to the other side of the shape and stick it on over there, I get a new shape, I get a parallelogram. Okay, so it still has a base of 6 and a height, if you like, a perpendicular height to that base of 4. And as you've seen, this triangle over here could easily fill in this gap and make a rectangle. So the area of the parallelogram is exactly the same as the area of the rectangle, 24 square centimetres. So in short, to find the area of any parallelogram, we multiply the base by the perpendicular height. Okay, we're not talking about this height here, this slanted height, just the perpendicular height. In other words, the height which is at 90 degrees to the base. Okay, so let's switch back to the pack and have a look at those questions. So here we've got a base of 4 centimetres and it has a height, perpendicular height of 2, so its area is 2 times 4, 8 square centimetres. Have a go at the others and then pause the video and click on play to see the answers. Okay, this one is 2 centimetres, its base, its height is 3 centimetres, so 2 times 3 is an area of 6 square centimetres. And part C, we've got a base of 5 centimetres, a height of 4, so 5 times 4 is 20 square centimetres. Okay, number 2, exactly the same, just without a grid drawn. They've just given you the length. So we're just going to times base by height. You can pause the video, have a go at these, and then just use this video to check your answers. There's nothing particularly hard on here. Okay, there's the answers to that page. Watch out for units on some of those questions. This one is square millimetres. This one, as long as these two lengths are in the same units, you can then multiply them together. So you could give your answer in square metres or square centimetres. Okay, number 3. So the areas of the parallelograms have been given on this question. We've got to work out the missing lengths. So this is just doing it in reverse. We know that these two things will multiply together to give us 27. So what does this have to be? Well, we could do 27 divided by 9, and therefore x must be equal to 3. And it's just in centimetres. Don't really, it's just in centimetres because it's just a length, not the area. This is the area. Okay, have a go at the other two on your own. I'll pause and finish them off. Okay, there's the remaining answers. And then question 4 is a couple of problem solving questions here. I'll go through these with you. We've got a logo created by joining 2 congruent parallelograms. So let's first start with that word congruent means, and what that means. Congruent means exactly the same shape and size. Might be reflected or rotated, but it is exactly the same shape and size. Therefore, it'll have the same area. Okay, so we've only got to work out the area of one of these parallelograms and then double it, and we've got the area of the entire logo. So we know that the base is 22. We know that the height of one of the parallelograms is half of this, so 15. So we're going to do 22 times 15 and then times 2 because we've got 2 of them. Some of you may have spotted that it's exactly the same as just doing 22 times 30. Anyway, put that in our calculator and find out what the answer is. 660 centimetres squared, or square centimetres. Okay, and then on number 5 we've got an algebraic problem. We know that if we times the base by the height, we're going to get this area, so we're going to set that up as an equation. Now when I times something which is already 2 separate terms by a number, I'm going to put that number outside a bracket with the 2x plus 7 in. That's how we'd represent this as an equation. Now you've got two choices here. You could either expand your bracket by multiplying by 15, or you could see if you can divide straight away by 15. Now, does 15 go into 615? Probably does. Let's have a little look. Yes, it does. Okay, so I'm going to divide by 15. Show my steps like this. And that will just give me 2x plus 7, the bracket. And 615 divided by 15 is 41. I would then subtract 7 from each side. That will just leave me the 2x. But I've got to subtract 7 from this as well, and that will give me 34. And then divide by 2 to get rid of that 2. So x is equal to 17. And you can always check it with an equation, put x back in to make sure that when you multiply these two things you get 615. Okay, thanks for watching. Next video will be on the next page.